Welcome back to another episode of Program That Part. Today we are going to program this part here, and this is to the bottom side of the Focus ST short throw shift kit. So to start off with, this is going to be our orientation for the first operation here, where you can see Z is up, X is over that way, and Y is back that way, and this is our piece of stock. So we have everything set up just like this. The piece of stock is 2.25 by 1.5 by 5/8 of an inch. The top of the part, well, for this operation, the top of the part is 0.13 inches down from the top of the stock. And that's just so we can get this facing operation in and just take it out with the Superfly real quick. Superfly going my normal 2500 RPM at 20 inches a minute. Didn't have to select anything, it already knew I needed to come down to the top part. So the bottom height is this face here, so that's as far as the cutter is going to go. And then everything else is left the same. And then I'm going to use a 2D adaptive around the entire part. With the shear hog I'm going 4000 RPM at 45 inches a minute, and it could probably be pushed a lot harder than that. I can push it to clear to 10,000 RPM and still be okay, but anyway, for this application we'll be okay. So we selected this chain right here and bottom height, so I wanted to go just below the bottom of the part, so I selected this face and went negative 5 thousandths. That'll just allow me to go a little bit below the bottom of the part so I can make sure everything is machined out basically. So with the shear hog I'm going a depth of 0.15 inches each time, and I'm leaving close to 10 thousandths on the side, and then I can come back later and clean that up with a contour pass. And then everything here is left the same. And then I'm going to adaptive out the middle part, and I'm going to use a 3/8 inch end mill, the Taz from Lakeshore Carbide. I'm going to push this thing to 7500 RPM at 35 inches a minute, and I'm going to select rest machining and from previous operations just so it knows that I milled everything out before. And for the top height I'm going to select this just so it doesn't think I'm going from the stock top, so that's why I selected this face here. And the bottom height is this face right here, so it just machines all this out here, doesn't go below this, so it goes between these 2 points. I'm leaving 11 thousandths radial stock to leave, and axial stock to leave I'm leaving 5 thousandths this time, so I can come back with a horizontal pass and clean up this floor and these little contours right here on these little pads, I guess you could call them. And that's what we're going to do next. Come in with a 1/4 inch end mill and clean up the bottom floor at 5500 RPM, 40 inches a minute. I selected this chain right here, and as for heights, the top height right here, and I selected to go below this top height negative 5 thousandths of an inch, just so it doesn't think to go onto this top height and clean this up, because it doesn't need cleaned up. So going 5 thousandths below this height right here, and the bottom height is this face right here, so this is what it's going to focus on cleaning up, and everything else is left the same. And now we're going to clean up the outside part right here with a 2D contour and a 1/4 inch flat end mill going 5500 RPM at 40 inches a minute. We selected this chain right here and left the clearance and height tab alone. This is all left alone, and this one is all left alone. And we get this tool path here, doing this in all one pass, and that'll be cutting the 9 thousandths of an inch that this adaptive left. And then we're going to come in and drill, and these will be holes for M6 bolts. So with a 13/64 inch drill, 3000 RPM at 10 inches a minute, plunge I guess you could call it, we're going to select these points on these holes right here, and then we will go 50 thousandths below the bottom of those. So we're going to go drill tip through bottom and then go an extra 50 thousandths just to make sure we're all the way through. And the feed height right here will be this, and the top height will be this as well. Just the feed height is 0.2 inches above this face right here. And I'm going 0.1 inches deep each time, each peck I'm going 0.1 inches deep at a full retract deep drilling. And that should be it for that setup. Now the next setup, we will flip this thing clear over, and we will orient this thing just like this, except Z, this will be in the same spot as we did last time, except Z is pointing up this time. We selected this face right here for the Z, and then for the X we selected this line right here. So it's going normal to, so perpendicular to this face for the Z. And then chose model box point to select it. We chose this point right there for the stock origin point. And everything here is the same. So all we're going to do here is adaptive, and we're going to use this adaptive as a facing operation basically. And this was for one of my prototypes, so that's really why it didn't need to be a super duper nice finish. So we just came in with an adaptive and made sure everything was out of there. So with a 1/4 inch flat end mill, 5,000 RPM, 35 inches a minute, I selected this chain right here, and then we selected stock contours so it knew that this is what we were supposed to mill out basically. If we didn't have that selected, then it wouldn't understand really what to do. It would just try to do this area right here. So whereas we have this big rectangle around here still that we need to mill everything out of. So once we select stock contours, then it realizes that we need to get all this out of here. Leaving everything alone on the heights tab, I'm going 0.15 optimal load, no stock to leave, even though it's selected it doesn't need to be selected, and everything else here is the same. And once we simulate all this, this is what we end up with. And here we'll just go through all the simulation, clearing out with the Superfly. This is the shear hog here. Clearing out with the Taz. The aluminum shredder is basically what it's called. And cleaning up the floor and contours, then drilling out. And then we're using a 1/2 inch end mill here, and then we're done. And these will be hand threaded with an M6. So there you have it. If you have any questions, leave them in the comment section below, and I will be sure to get to them. Thanks for watching.